All right, everyone. So for today's lab, this week's lab, I should say, I wanted to give you a quick introduction to the topic of rare earth elements. So you might not be familiar with any of these names of these elements. They do appear on the periodic table of elements, and as the name suggests, they are rare. They don't occur in large quantities. You have to mine them out of the earth, and we use them for a number of products. You might not be familiar with what products and what they're used for, but let's just get into it. So, what do these things have in common? So here's a flat screen LCD HD TV, um, highly pixelated, very good picture. For all these things I show you, don't mind the brand as much as what it is. So, like I said, it's a flat screen LCD HD TV. This is what? Well, many of us are probably watching this lecture on something like this, a, a nice laptop with a nice LCD screen, a battery that it doesn't have to be plugged in all the time. So this is a nice piece of equipment. What about this? This is a Tesla, but not so much as it being a Tesla, but it is an electric car with a long-range battery, right? You don't put gasoline in this car. You can run it off electricity. What is this? Well, this is not an incandescent bulb. It's a fluorescent bulb, and this bulb is more environmentally sustainable in terms of how much energy it costs to light up a room and how long it lasts, but maybe costly in other ways. What about these windmills? What do they have in common with what we've been talking about so far? What do windmills do? Well, they produce energy from the movement of those pinwheels, basically. What about this? This is fiber optic cable for high-speed internet. Fiber optic cable, that's what that looks like. And how about this? Well, that's an MRI machine, magnetic resonance imaging, to look and see if there's any ailments going on in a patient. How about this? Here's the newest iPhone. I'm sure many of us either have this or something similar. I have an older one, but it's all the same. It has very similar aspects of a nice screen and camera and a battery. Well, clearly you understand where I'm getting at is all of these things have rare earth element components that without those rare earth elements, they would not work, okay? They won't work the same way. For example, here are the elements of a smartphone. Just in the screen, there's indium, oxygen, tin, aluminum, silicon, oxygen, potassium, right? Tons more. In the electronics, there's others like copper and silver and gold and tantalum and nickel and all of these words. Silicon again, oxygen. In the casing, there's carbon and magnesium and bromine and nickel. In the battery, there's lithium and cobalt and carbon and aluminum and oxygen. And all of the things that we talked about have either electronics in them, a screen, a battery, something to hold the casing. All of these things are going to be mined from the earth in some way. Now, here's an example of what the problem is in the US with rare earth elements. So if you take a look, this graph is representing the mining of rare earth elements in the US, in China, and in the rest of the world. Now, at the start of the 1960s, color television was invented for the first time. And as you can see, before that, there's really next to no rare earth element mining going on anywhere in the United States or China. Most of it's happening in very low amounts in the rest of the world. But after the advent of color television, this starts to kick off, including openings of mines in the United States and China. And it starts to really just increase and increase until about 1980, where the U.S. mines start to close. And we'll get to that why that's happening. But the U.S. is starting to close their mines, so the production goes down and down until the last of the mines are being closed in the United States. But that doesn't follow the same trend in other countries. You can see it just continues to go up and up and up. And the reason for that is China and other parts of the world, but mostly China, are able to sell these rare earth elements. And also, by the way, they have a lot of rare earth elements within their country borders, and they're able to sell them to the United States and other countries at a relatively low cost. And so it was more cost effective for the United States to just import rare earth elements. However, China has now adopted the stance, and has adopted the stance for many, many years, that because they have so much of this, they can sort of hold the rest of the world at ransom, for lack of a better term, and increase the costs of these by quite a lot. So as you can see, some mining has increased since 2010 in the United States, but it's nowhere near enough of the amount that we would need to make the products that Americans want. And so we are left with a decision. Do we continue to import from China, or do we try to produce our own? Now, here are what rare earth element mines look like. Maybe some people think this looks good. Me, as a lover of nature, this looks like a nightmare. But it is, part of the world that we live in. And if we want these great technologies, this is pretty much how we have to do it as of right now. We don't have any other way around it. Um, there are consequences of this mining. China wrestles with the toxic aftermath of rare earth mining. It's been a major source of rare earth metals used in high-tech products from smartphones to wind turbines. But as cleanup of these mining sites begins, experts argue that global companies that have benefited from the access to these metals should help fit the bill. Now, depending on your, I guess, political leanings, you would have to, argue whether or not you believe that the companies should be responsible for cleaning up. In my opinion, obviously they should. They've made billions of dollars off of it. They should be responsible for what they've done to the earth. In terms of things like this, here are the retention ponds that spew this toxic black sludge, extremely toxic, killing all organisms that used to live within these ponds and lakes, and often causing cancers to the humans that live near them. So very unfortunate side effect of the world in which we live in, of high tech. Again, here's just an image of what these things look like after. This is not what they look like when they come out of the ground, but they come out of the ground, and then after refining, they look like this, and they can be used in, like I said, all of the high-tech products that we love and hold dear. Like I said, China has decided to limit the export of their rare earth elements. So other countries, including the United States, are looking into how to feasibly mine rare earth elements within their own borders. Do we think this is a good idea? That's up for you to decide, and part of this week's lab. The first part is you're going to figure out how much rare earth element that you use in your lifetime. And then I want you to make an argument for or against a rare earth element mine. But I want you to argue it knowing that it could pop up in your backyard. It could pop up a few meters from your school, or a few hundred meters from your house. And you have to weigh the balance of the good or the bad. The good being that you can continue to access the technology that you want at the prices that they're going for. If you argue against it, you have to deal with the fact that the technology that you already think is expensive would go way, way up in price. But you also have to argue and understand the side effects that it has on the earth, and the health benefits versus costs that would present as well. So I'd like for you to make that argument. This is what it's going to look like, something along this, where I give you the type of mineral or commodity. I give you the amount used per American in a lifetime. On the left side of the slash is the pounds. On the right is the metric tons. I want you to look up via internet sources the cost per pound of aluminum, cost per metric ton of aluminum. You might have to do a little bit of math here. If you find how much it is per metric ton, you have to do some math to per pound and vice versa. find the value used in a lifetime, and then per year. And we could say you can do whatever you want. 100 years is a lifetime, 80 years is a lifetime, 85, whatever the average American life is, you can use that. Whatever you use, just make it clear. And then there's going to be a second part where there are some questions, but that will go up under the words, the file word name, Mind Over Matter worksheet. So download that, have some fun with this lab, and learn something. So let me know if there's any questions on this, and I'll see you in the next one. Bye, guys.